Alright, today's lesson is 3.1 and it's Dependency Statements, Qualitative Graphs, Introduction to Functions. So this is our function unit, 3.1. So get out your notebook and we'll take some notes. This is going to be a long lesson, so you might grab a snack, something to drink, and just follow along and take notes. Alright, first of all, let's define function. Function is a dependency relationship where one thing depends on another. So write that down. A function always has an input variable and an output variable. Write that down. And to be a function, each input can give you only one output. That's very important. Each input can give you only one output. When we talk about inputs, there are different names that we will use, or different ways we will refer to the input variable. The input variable is always your independent variable. It is always the cause to an effect. It is your x values. X values are your input variables, and it is also the domain. So you need to know that these all represent the input. The output variables are called your dependent. They are dependent on the input. And it is the effect. You have a cause and effect. The output is the effect. It is your y values, and it is also called the range. So you need to know the different representations of output. So one of the ways you'll hear this is a dependent variable depends on or is a function of the independent variable. And your output depends on or is a function of the input. So output depends on the input. Output is a function of the input. And the effect depends on or is a function of the cause. The y values depend or is a function of the x values, and the range depends on or is a function of the domain. So make sure you have all of that in your notes. Alright, let's move on. Alright, so for the given information, we're going to do some examples. Determine if it is a function. If it is a function, identify the independent and the dependent variables and write a dependency statement. If it is not a function, write no. So look at example 1. The amount of time you study and the grade you make on a test. Write that down. The amount of time you study and the grade that you make on a test. So is this a function? Is one dependent on the other? And I would say yes, that is a function. Now identify the independent variable. The independent variable. So remember, the independent variable is the cause, right? It is your x values, it is the cause. So the amount of time you study would be the independent variable. Study time, let's say. Okay, that's the cause. The dependent variable is the grade that you make on the test. Your grade depends upon how much you study, usually, and it is the effect. The cause was the study time. So the dependency statement says, so I would say the grade that you make, let's see if I can write this, depends on or is a function of, or is a function of the amount of time you study. Alright, so the grade you make depends on or is a function of the amount of time you study. Let's look at example 2. It says the level of education you have and the salary you are paid. The level of education you have and the salary you are paid. Write that down. So you want to know, is one of these dependent upon the other? And for the most part, I would say yes, this is a function. The salary that you have depends upon the level of education. So what is the independent variable? The independent variable is the level, it is the cause. Remember, the level of education that you have. And then it says the dependent variable would then be the salary that you're paid. So then the salary depends on the level of education. So that's the way we would write the dependency statement. And then we would say that salary depends on, is a function of the level of education that you have. So that would be a function statement. All right, let's try some more. So example 3 says the day of the week and your shoe size. Does one depend upon the other? Well, in this one I would say no. That is not a function statement. They are not related in any way. So write that down and write no. All right, example 4. The time you spend on a volleyball practice and how well you play in the game. So write that down, the time you spend at volleyball practice and how well you play in the game. Would that be a function? I would say yes. And the independent variable is the cause. So the time you spend on volleyball, so that's what I would put as the independent, time spent, volleyball practice. Just summarize. And then the dependent is going to be how well you play at the game. It is dependent on your practice time. Okay. So the dependency statement says that how well you play in the game would depend upon or is a function of the time spent on volleyball practice. And this is how you would write that. All right, look at example 5 and write it down. The types of coins in your pocket and the amount of money that you have. The types of coins in your pocket and the amount of money that you have. Well, yes, I would say that that would be dependent. And the independent variable would be the coins in your pocket, because the money depends on the coins in your pocket. So the dependent variable would be the amount of money that you have. And then the statement would be that the amount of money you have depends on or is a function of the types of coins in your pocket. So this is the way we would write that. The amount of money you have depends on the types of coins in your pocket. So your job is to be able to understand what is an independent variable and what is a dependent variable when we see these statements. All right, let's move on. Okay, the next concept we'll cover in this lesson is quantitative graphs. So write this down, quantitative graphs. A quantitative graph is a mathematical representation that illustrates information about a situation. Analyzing these graphs helps us to understand situations and help us to make predictions and draw conclusions. So this is an example which you want to have in your notes as well as that definition. You want to have this in your notes. This qualitative graph illustrates the altitude of a pelican searching for fish to eat. The pelican starts on the ground right here at 0. This is your altitude. This is the time. So you want to draw that. And then it says the pelican starts on the ground and then flies up in the air. So here we go. Here's the pelican going, taking off. And then it flies in the air at a constant height. So the height is constant for a while, right here. And then it says it dives down into the water. So here we go, diving down into the water. So this is called a quantitative graph. So your job is going to be able to match some different graphs with situations and be able to relate and draw some of these as well. So let's look at examples. All right, so the first example, it says choose which graph illustrates the situation. So what I want you to do is I want you to write down example 6 and write down this. The farther the car goes, the more gas it uses. And then I want you to choose, we're going to choose one of these and then you draw the one that we choose in your notes. Okay, so the farther the car goes, so here we have distance, the farther it goes, the more gas it uses. So here's your amount of gas. So as you go along, you start up here with this gas, but as you're going, you're losing gas. So that could be it. Here's the amount of gas. So does your gas fluctuate as you drive? The amount of gas that you have? No, so that can't be it. The amount of gas, so the more gas that it uses, is it using more gas? This is like it's using less gas. This is using more gas, so this could be it. The amount of gas and the distance. So here we go, the distance, the amount of gas is going down. So we're using gas, but it never gets to zero. It looks like it's just going to stay constant right there. So which one of these would work? It looks like the amount of gas it uses, is it the amount of gas going to go up the farther you go, or is the amount of gas going to go down the farther you go? So to me, I would select this, because this is the gas that you have, and your gas is going away, and eventually it's going to get to zero if you just keep going. So I would say this would be the right one. All right, let's do another one. All right, example 7. As the length of the side of a square increases, its perimeter increases. All right, so here we have the perimeter. So the perimeter and the side length, perimeter, side length on all of these. So as your side length increases, the perimeter should increase, right? So if you look at this one, the side length increases, but the perimeter stays the same. The side length increases, but the perimeter goes up and down. The side length increases, but then it stays the same, but then jumps up right there. It doesn't make any sense. So this one has to be the right one. The side length increases, the perimeter increases. Okay, here we have example 8. We're going to draw a graph now. Susan is walking towards Tom at a steady pace. So here, let's draw this graph, write this down. We have time elapsed, so the time is going by, and distance from Tom. So Susan is walking towards Tom, and this is the distance from Tom. So distance from Tom, we would say this would be maybe 0, right? And we don't know what the time is. We don't exactly know how far they are. But let's just pretend. So the independent variable we have to identify is either going to be time elapsed or distance from Tom. And remember we said that independent was usually your y, and the dependent is your, I'm sorry, the other way around. Independent is x, and dependent is y. So this is going to be your x, so that's the independent, and then y is going to be your dependent. So that means the independent variable is the time, and the dependent variable is the distance. So distance depends on time. Distance from Tom depends on time. So now if we're walking towards Tom, that means we're starting at a distance away from Tom. Say we're starting here, and as time goes on, we're going at a steady pace. We're going to get closer as time goes on to Tom, and then eventually we'll meet up with Tom. So down here is where we're meeting up with Tom, because your y is 0 right there. All right, let's try another one. Actually, we're not going to try another one. I thought we were, so let's just move on. All right, in math, we use equations to represent relationships and situations. However, not all equations are functions. Some equations are functions and others are not functions. So kind of summarize that in your notes. Basically right here, some equations are functions and some are not functions. So here we have an equation such that y equals 3x plus 5. It has an input, so it has an x, and it has an output, which has a y. And here's another one, such as y equals x squared. It has an input, it has an x, and it also has a y. So these would be, which one of these would be functions? So write these down, and which one of these would be a function. Remember, to be a function, each input can give you only one output. So which one of these, if you have an input, it gives us only one output. One way to tell whether an equation is a function is to do a table. So here we would have y equals 3x plus 5. If I substitute for x a negative 2, 3 times negative 2 is negative 6 plus 5 makes negative 1. If I substitute a negative 1, I'd get negative 3 here, plus 5 is 2. 3 times 0 is 0, plus 5 is 5. 3 times 1 is 3, plus 5 is 8. And 3 times 2 is 6, plus 5 is 11. So for every x, I only get one y. So if you match those up, you can see. Now if we look at this one, y equals x squared, and I substitute a negative 2 for x, so negative 2 squared would give me 4, negative 1 squared would give me 1, 0 would give me 0, 1 squared would give me 1, and 2 squared would give me 2. Now does each x have only one y? Well, yes, the y does repeat here, so it looks like we have ones here. This is actually supposed to be a 4, not a 2. So it looks like the y repeats here, but each x can only have one y. But so this is a function because the x's don't repeat. So the x's cannot repeat, the y's can. So both of these are functions. So I'll say that again. The x's cannot repeat, but the y's can repeat in a function. And you will have to identify a function from a table of values. Alright, so the next word you need to write down is function notation. Function notation is used with equations that represent functions. So write that down. It's used with equations that do represent functions. An example of a function is this: the amount of a total bill T and the number of meals bought. Is this a function? Yes. And the independent variable is the cause. So the cause is the number of meals. And the dependent is the amount of the bill. So we'll just put the bill. And that's usually common. So usually cost is always dependent on something. So the dependency statement is that the amount of the bill is dependent or is a function of the meals bought. The amount of the bill is dependent or is a function of the meals bought. Alright, so to represent the situation as a function, we use what we call function notation. This is function notation. T of M is how this is said. So the total bill is a function of the meals bought. It depends on the meals bought. The M is your input and the T is your output. So the number of meals is your input and the total bill is your output. And we will use function notation to solve equations or functions and to write functions. Alright, let's move on. Okay, these are the last two examples in the notes today. Example 9, the length of the side of a square S and the area of the square A. So is the length of the side of the square and the area, are they a function of each other? I would say yes. Okay, the independent variable is the cause, remember, and the cause is going to be the length of the side of a square, so that would be S. So we're going to use a variable. So the length S, this is the independent, and then you have the area, which is the dependent. So the area depends on the side. So function notation is the area is a function of the side. So you put the dependent first because it is a function of the independent, and the independent goes inside parentheses. And the way we would write this is the area of square depends on the length of the side. Okay. Now let's do number 10. Let's read this and write it down. The amount of money made, M, and the hours you work, H. Is this a function? Why, yes, of course it is. And the independent variable, remember, is the cause, and the dependent is the effect. So the cause is going to be the hours that you work. That's the H. And the dependent is going to be the money that you make. And remember, money is usually always the dependent variable. So the function notation, you put the dependent first, the money, is dependent on the hours that you make. Okay, and then the way you would write that is just write it out. The money that you make is dependent on the amount of hours that you work, and you write that as a sentence. And that's how you write it. All right, so hopefully you've learned a lot today. Remember, this is function notation. We talked about what a function was, input and output, independent variable, dependent variables, x values, y values, cause and effect. And then we talked a little bit about the quantitative graphs so that you can match a graph to a situation. And then we talked about function notation. So that's it for today. Have a great day.